How's it going, everybody? Standing between you and them setting up for dinner. So we'll try to keep this on schedule, but I'm around all day tonight, all night tonight, as well as all day tomorrow. So if you have any questions and you want to talk in person, to do that. So we're going to go. How many people have read the research on this that we released earlier in the year? A couple of us, okay. This talk is going to be different than the S4 talk, but it'll look the same here and there. But bear with me, and we'll have some fun, okay? So how did we reverse engineer multiple industrial radio remote control systems? One of the first things, that we did is all of us on this team, it was 7 of us that work for Trend Micro, and what we did was we started noticing something. I took this picture in December from the Rainbow Bridge in Tokyo, and one of the things that you notice, and Tokyo is really building up right now for the Olympics in 2020, but this isn't unique. Everywhere you see these cranes. One of the things that we noticed is those are also unmanned cranes, so there's not a little booth with a guy in it, and it made us really start wondering and thinking, how do these work, and are they potentially susceptible to attacks? And not only were we looking at the big construction cranes, but we were also wondering, in the systems such as the overhead cranes as well, do they use the same types of systems? So I went back to my life as a consultant and remembered that many times we saw things like this. I never did an assessment on them, but we knew what they were. Does everyone know what that is? Okay. This is one type of controller. That's really blurry, sorry. This is a collection of just images of some of the ones that we've tested, looked at, and things like that. But in short, one of the first things we did was try to do a survey of where these things would be used. And so they were industrial hoists used them, mobile hoists, concrete pumps, agriculture, logistics, forestry, drilling, operations, industrial automation, material mining, and pretty much I just said every industry that I could think of is more or less using this in one way or another. And I've ran into them in many places. Power plants have them, nuclear power plants have them, just pretty much everywhere uses them. So pretty much every industry and every sector is covered. More interestingly, though, is these are the vendors that we tested based off of location. We found several large vendors based on the highlighted countries. Most of them vendors have been operating for decades that make these. So it's a very mature business, and it's tens of millions in revenue that they do annually. So how do they work? This is one thing that everyone, when we start doing these things, so I have my little crane over here. It's powered on. So how it works is you have to start it, and it clicks, and when I push a button, the transmitter sends the signal to the receiver. The receiver then operates the relay, which then drives the motor. Okay? Pretty simple, okay? That's how this thing works. So then you can say pretty much run anything that can take signals. So it doesn't have to necessarily be a crane. It can be pretty much anything that uses these. We found, after doing some of this initial research, we found them using big lawnmowers, seen those being used. I have a really good video that I found on YouTube of the exact same systems being used in continuous mining. One person I was talking to about that said, well, that would be really neat if you could do that, do an attack of a continuous miner. But I was like, yeah, but it's a couple hundred, it's a couple kilometers in the ground. So if you can get an RF signal to penetrate that far, you're doing pretty good. So what we started with doing is we took software-defined radios and we started listening to what that was. What was that in the air, and what kind of security there could be. We mainly used a Edis Research B210 or the Nuan Blade RF X115. So this is a GNU radio flow graph of one of the ones that we made to do specifically a replay to test if it would work within GNU Radio. And I'm going to show you a quick video of us recording one of the vendors. This is JUCO. And you can see in the background, the crane's moving. We're capturing the signal on the display. Next video you'll see is the controller sitting on the ground. The batteries are removed. That's why it's face down with no batteries. And we're replaying. And you can see the relay lights on the controller itself turning on and it moving. It was really this simple as to capture, in this case, the down within GNU Radio, replay it, and it went down again. One of the things that we noticed was we decided to capture multiple signals. So message 1, message 2, message 3, message 100. What we noticed for most of the vendors that we were looking at, all the messages were exactly the same. If you were always pressing down, the signal was always exactly the same. The command, the byte strings, everything matched. So on all the vendors that we tested, replay attacks worked. So very cheap, pretty effective, easy to move. And now toy cranes are fun. I mean, toys are good for kids, but sometimes you want to play with the big boy toys, and here is an example of a replay attack on a live system with permission from the facility owner. So what we're doing here is setting up all of our commands. There is the Blade RF X115. And there you go. It's moving. This was just simply capturing a signal and then just replaying it. And as you can see, it moves pretty fast. Things swing around. If it had been holding something, we could move it around as well. So instead of just playing with little cranes, we played with the big ones too. So we started capturing the signals for up, down, north, south, east, west. This worked if we had the radio for that one radio. If we had another radio, we went over to it, replayed the same signal, it wouldn't do it. That means there's some form of authentication that the controllers are doing. In most of the cases, what we saw. Which is fine, but you have to capture everything. So what we really wanted to do was work on arbitrary command and execution. To do this, we took apart the case, we opened it up, we looked at the parts, we noticed that that's a CC1120 chip that was in this specific model. And then we started doing some RF analysis on it. And so we captured the signal. Now what? Has anyone in here tried to reverse engineer RF signals? Yeah, it's pretty challenging. So we captured it. Now what do? This is where we developed a tool set that with a logic analyzer attaching to SPI, we could pull the messages out of the chip and see what the signals were looking like. So we created a tool, as I said, that emulates the SPI operations. We went into depth at this on our S4 talk from earlier in the year. My colleague on the research, Jonathan Anderson, can speak way better to this since he's the one who developed it. So go watch that talk and read the paper. I'm going to talk more about some of the other stuff that we did. So the interesting thing is you can see what is being accessed, set, and programmed over SPI. Based off of what we learned, we created new GNU radio blocks. We then made a custom code and implemented a larger GNU radio flow graph that implemented that. So again, this was really good for us to capture and replay, but now we can start breaking it down, tweaking, and pulling stuff apart. So, as we said, it was a CC 1120. If you look at the spec sheets on the CC 1120, we get kind of a packet to what it's supposed to look like on the radio. There's a preamble, sync words, length field, address field, and the most important thing, which is the data field. So then we started looking at the data field. Okay, what is it? Where can it be? So one of the first things we did, this was again with the JUCO radio, we noticed a 0, 1, 2, 3, 4, 5, 6 as the first byte. So we concluded that that is the sequence ID. When we started sorting multiple and lots of transmissions and stuff like that, we could look and see that with a fixed sequential ID, the next 4 bytes looked pretty interesting. Those always tend to be the same. So what's going on and what is this? So we then realized that when we opened up the case, this thing up here was also the thing in the software that was called the pairing code that pairs the transmitter to the receiver. So what we then did was change our pairing code to all zeros. Okay. And then, as people see what we're doing here, what we did was with zeros, and you XORed with everything that we found here's the pairing code in Little Indian. Okay? The next chunk, and those are the commands right there. So what we were able to do at this point in time is take a command, now that we know how to reverse what the pairing code is for that system. We can take a command, and now we can say, record somebody doing up. Okay, so they're raising the crane. So the next thing we can do is change that up, since we now know all the commands, change it to an EStop. So we took your up, pulled out your pairing code, made our own packet that says EStop instead of up. More or less, it can be a DOS of production. So we have a video of this actually working. So this is my colleagues in Italy doing this one with the JUCO that we had. And so what happens here is it starts. It has its own little function. You have to start it, pull it, the relays are on, off. So we'll have to start it again. Relays off. It's on again, off. That could be pretty frustrating if you were trying to operate a crane. It just keeps shutting off on you, especially if you're trying to move it, trying to do something critical. So command injection, we have that now. We were able to do command injection on all the vendors. Slightly harder, took a little bit more time to figure out. And by that, we also have what I would call EStop abuse, just showed it, and then malicious repairing. What is malicious repairing? I can go and buy a transmitter myself on eBay, and now I know how to program it with your pairing code. Now I can walk around, instead of with all my SDR equipment, I can come to your site and have this, and not look as fishy as some man with a bunch of antennas hanging out of his backpack. So, what about if we did malicious reprogramming? We wanted to see if we could reprogram the firmware on some of these to be malicious. Short of the story, yes. Here is the SCADA radio controller, which is this one here. Does anyone know what that is? So it's JTAG. Malicious firmware. So in essence, what we were able to do is pull clear text passwords from transmission. We had unprotected firmware, and there's forgeable integrity checks with backdoors. My coworker in the Philippines did most of this work, so that's why I'm not going to talk very hard about that. He knows a lot about it, and if you're more interested in how we did it and stuff like that, reach out to me, and I'll put you in touch with him. But we were able to find pretty much everything we needed to put rogue firmware on some of our devices. So with that, we have malicious repairing done. What about remote, stealthy, and persistent attacks? We have this tool set that we built that we named RF Quack. The code is at github.com/trendmicro/RF Quack. And the idea here is we wanted to make something remotely deployable in this case to do this specifically for this, but turns out we built a tool set that's actually pretty handy for other assessments, other tips and tricks and things like that. So there's a little video here of it working, maybe? Video? Yep, it's going. Maybe? Yeah, here it goes. So it can be remotely controlled via Wi-Fi or 3G. New protocol, they're as easy to add as just making some C code. Can be hidden anywhere. As you can see, it's pretty small. There's a command line interface. I'll show you a quick demo. It listens for configurable packet patterns. And then it goes through, and no USBs or Bluetooth limitations, and it supports virtually any radio chipset. So I'm going to show you here we can recover supposedly secret codes used by pairing. And so it just sits there and listens, and we can get this stuff and remotely access it and be able to do this. And we all saw how small it was. The unmasked packet here shows a 4-byte pairing key. This is also the JUCO again, guys. So we can set the tool to automatically manipulate the packets, retransmit, effectively implementing a variety of attacks in real time. Okay? So if you have that system or are more interested in it, go to our GitHub page, the schematics for boards and everything like that, because it's running a little custom hardware, is there. You can also use multiple chips and things like that. It's really a neat and handy tool that we built to do this. So as I said, we can also do all the attacks that we've kind of mentioned. This one video is going to show them to you using that smaller, remotely deployable device. And pretty much that was just sending out the EStop packets. You can see them turn off again. Okay. The one thing I always like to bring up about this, which is that was really neat. And tomorrow there will be a really good talk downstairs, from what I understand, about how to do sweeping and looking for those kind of reconnaissance devices in your buildings and in your facilities and things like that, which is neat and all, but there's this one time that I moved this crane with my watch. And I'll show you a quick video of that. This happened at S4. Does anyone in here know what a good watch is? Okay. A good watch is a watch built by Travis Goodspeed. I'm actually wearing it right now. It's a Casio watch that has a custom board in it that uses the whole watch itself to be fairly dependent. Uses the watch band in this case as the antenna, and I just moved the watch. Move the crane with the watch. I'm not going to transmit here in Sweden. That I don't want to get in trouble. So that comes back to when I was introduced, and this is going to be a good discussion here, I think, and something we haven't really talked about before, which is how did the disclosure of this go? While this chart up here says there were 3 vendors that released a patch. Initially, only 1 out of the 7 vendors released a patch. We felt that was pretty sad. One vendor we spoke with in person said that no one will ever be able to do these attacks. I read an article from a couple weeks ago that was released here in Sweden that was said, which is, in theory these work, in practice no one could ever do it. Which is part of the reason why I wanted to also show the videos of us doing it on the real systems, because it's not only theory, you can do it. There's absolutely no security on any of these protocols. All right. Another vendor that approached us actually thanked us for the paper. They're one that we haven't tested. And they said that they are going to use our research as part of a existing safety standard, IEC, I think it's 62745, which is the minimal requirements for functional safety for remote controls. They're going to amend it to include that replay attacks should never happen. That if you want to conform to the standard, you have to test that replay attacks don't work. One vendor threatened us with legal action. And then they decided Trend Micro owns or bought Tipping Point a couple years ago. Part of the acquisition with Tipping Point was the 0-day initiative. We internally use ZDI to release and do all of our disclosures through. We don't get paid. They don't buy the bugs off us. They just help do that process. And thanks to the work with ZDI and my own team, they claimed they were going to patch it. We have not seen any evidence of the patch, but they didn't take legal action against us either. This is also the company that said, we're going to sue you. Oh, what's a vulnerability? And it's really painful to say this, because after many years of working in this space and dealing with multiple vulnerabilities and multiple vendors, and I used to work with Reed, and we've gone through this process many times, that one would think that eventually in our space that the vendors would be more willing to work with the researchers to help fix the problems, to help make sure that everyone's more secure. Now, our entire process was very painful in this, which actually took 30 more days. We gave vendors, on most cases, 30 more days than our 90-day ZDI policy. to disclose. One of the things that also bothered me about this, and I don't know if anyone else knows this, but right there, this company said that one product was end of life, therefore the vulnerability is closed. No one will look into it, no one will talk about it. So and we try to have conversations with them going, we know it's end of life, but we saw these in real use still out there. I found that actually pretty surprising, that is actually something you can say, is that this product is end of life and the vulnerability disclosure process is done. We did get a CVE for it, but there will be no patches, there will be no further discussions about it. It's done. We did release 2 O-days on this, but as you can see, they were pretty simple O-days. So one of the things we want to do more of is use open technologies. We think vendors should do this, such as Bluetooth or any of the other open standards. Stop using, every one that we tested had a different protocol. Most of the sub-gigahertz radios have little to no security in them, so we need to move away from those radios. Okay. Adopt rolling codes. I still remember the day we were in I think it was Taiwan. We were getting together as a team. We had our team meeting, but we were working on our projects. And we were in a meeting room with this project, and we finally figured out the JUCO. They're encoding via XOR. Because we kept trying to think that it was some form of security, but it wasn't. And my coworker, Federico, goes, I can't believe my garage door has more security than a crane controller. So rolling codes have been figured out. Key fobs use them, garage doors use them, lots of things use them. It's not hard to implement. They're not hard to break, but it's at least replay attacks would stop happening. So we need to start taking those steps and start moving in the right directions. In the cases that we saw, there was lack of any software or firmware protection. And generally, we just need to do more to protect the firmware. We need to promote, as users of this, we need to make sure that our vendors know of these risks, that you also want to make sure you're being secure and adopting to open technologies. Maintenance periods, do your updates, because as we mentioned, there was patches released. We haven't, I think Reed and Jimmy were talking about this earlier, we haven't got those patches. They wouldn't release them to us. So we haven't tested whether the actual security fixes were actually implemented. They claim it is. That's good enough for the vulnerability disclosure process. Everyone's happy. But go ahead and update those if you can, and then test them, see if it works. Everyone should be testing their own equipment, and everyone should be trying within legal means. A lot of these radios work in frequencies that aren't open for just everyone to transmit in. It's one of the reasons why I'm not going to do any live demos here of me running software-defined radios to control this crane. So in conclusion, patterns of vulnerabilities, we saw no rolling codes, there's weak or no encryption at all. It turns out from talks with people, what we think JUCO is doing was trying to make sure that they were not producing too much power in one area, and so they were trying to use an XOR to make sure that they were spread across where they need to be and to stay within, to get the FCC license. There needs to be security programs and awareness in the industrial IoT space, OT, SCADA, whatever, ICS, DCS, whatever we want to call it. We need to do good awareness of radio vulnerabilities and radio frequencies and what's being used and how to break them and how to fix them. We need to do better with this. If you want to read the paper, you can find it here. And at that point in time, thanks.
Thank you, sir. Very interesting talk.
Yep, thank you.
I'll put the clicker here. Can we get a few answers from you?
Yeah, sure.
People are curious. So I'll do the same as with others. I'll start from top.
Yeah.
Is it conceivable that you could override safe working limits, for example, speed governors, weight limits, etc.?
The physical protections, such as a speed governor, likely would not be able to be overridden in this case. So those are usually limits that are physically in place. And that would be like saying, if you hold that button down, does it go faster? No, it doesn't. All we're doing is acting like the transmitter.
Yeah, makes sense. So there are setups that require legacy radio communication. So how do we overcome this issue?
Yeah, we need to start talking about procurement life cycles of some of these systems as well, like we've done with a lot of the other systems that we've overcome issues with. It's, you know, when you buy something and you expect it to last the lifetime of the crane, that lifetime of the crane is 30 years, you're never going to change the controller. Then we have, you know, you need to start figuring those things out where maybe we need to update the controllers before the crane gets updated, those kinds of things. And that's, it stinks to say that, but buying new systems is probably the better way to go.
Right, so there's not much we can do with the stuff that we already have?
No, as I mentioned, the vendor that told us they were end-of-lifed and they weren't going to fix the problem. Now, if we did not test one of their newer models, but I can almost guarantee you that that newer model has that same problem. Just because when we were looking at all the other vendors, that it didn't matter. Now, this is kind of more modern, the wireless communications. A lot of cranes are still cable driven, like from the pendant, as those are called, are tethered to the receiver themselves. In a lot of cases, the ones where people are sitting in the booths, they don't are there. So it may not be as big of an issue in your facility if everything's still wired together versus doing it wireless.
So you said that modern systems are more vulnerable because they're wireless.
They can be. So there's a harbor in the Netherlands that has gone completely wireless for all their shipping and containers. And because it turns out that they're really worried about the crane operators who get paid lots of money, but they all tend to end up with vertigo pretty quick. And so they've moved all the operations into a control room where they're all done wirelessly via a monitor and controls in a room instead of being out there on it. So it's there, we just need to work. And there are some crane systems out there that are using more standard protocols such as Bluetooth. With Bluetooth you have the range issue where a lot of these tend to go pretty good distances that you can control cranes.
Yeah. So is it possible to use jamming? Or how do you consider jamming and how it will impact production?
So that there's no frequency hopping for the most part in any of the ones that we saw. So if you can oversaturate the bandwidth and where that crane is operating, you can jam these systems as well. And that would be really unfortunate if someone's really trying to get something to move or stop moving. So in the case of the one I have here, when you're holding down the button, the signal is constantly saying up. It's constantly up until you release the button. We did have some cranes that were on to help save battery life. On button push up, it would send a signal, and then on button release, it would send a signal. So could you, in theory, snipe off that packet that was for the button release? Yeah, and then it would just keep going. And somebody was still sitting there hitting it.
Nothing happens, okay. So would you say that vendors are reluctant to adopt to modern standards and chips like Zigbee or Bluetooth you mentioned, or are they simply not a good option for these applications?
We keep asking if they'll do that, and we don't really get a response back. I think they'll be very open to it, but rolling your own sub-gigahertz tends to be more common than adopting a more expensive standard like Zigbee and buying the Zigbee chips and things like that. It's also, they want it to make sure it works for safety concerns and things like that. So it's just something they're going to have to play with and make sure that they are getting the safety taken into account as well when they're looking at different protocols.
But otherwise it would be theoretically possible?
Yep.
Okay, that's good. So did you find any products that were significantly better than others?
No.
They were all... Okay. Simple answer, okay. So...
as I said, with like the JUCO, we were really hoping that when we couldn't see the commands, something was going on to help protect it, but we had several of our teammates going, oh, this has to be encryption. And I said, but a replay attack works, so it's not encryption. Something else is going on. They're just trying to mask something. And it turns out it's to really help with the pairing. That way you can actually receive the packet, decode it with the pairing code, and then you have a command. It helps in a situation where you have more than one of these systems nearby because they ran on the same frequency, all of them. So you have to have something that does something so you're not hitting up and all your cranes are going up. Some systems use dip switches as well for varying the frequency between the transmitter and the receiver.
I'm just curious, did you ever find any way of messing with the firmware on the receiving side over the radio?
We never did the receiver firmware. We did the transmitter firmware, but the processes are roughly the same, in which a lot of them, because you have to use that same JTAG USB dongle that showed in one of those pictures, that also you had to go to the receiver and tell each side which the pairing code was going to be.
Right.
We didn't really extract the firmware off the receiver.
Right. Okay.
We were really focused on doing the transmitter to see if we could put rogue on the firmware on the transmitter.
So this is kind of relates to another question that you already answered. So what's the solution for vulnerable radio communication? To replace it? Equipment?
You need to do a risk analysis of yourself to see if this is a risk to you. How far are you away from where somebody could sniff, see the signals? And one of the best ways to do that is go around and get a software-defined radio and see how far you are away from the crane, and can I see it? Can I actually see it and look at the packets? If I can receive them, then somebody can send them. And you can always use directional antennas and boost your signal so you can receive better, but you need to see how much you're spilling out of your facility. And if it's something highly critical, highly sensitive, or you're moving pallets of fertilizer, or are you moving the lid off your reactor? Those are two different things, and you have to decide which one's more critical for you to fix these issues now.
Sure. Would it make sense to create some kind of detection fence using SDR or something to see if there are signals coming from an unknown source or unexpected source?
I think that's always a good idea to make sure that you should always be doing sweeps of RF in more critical facilities to make sure that something didn't get placed in or something rogue's there,
Right.
causing issues. I mean, you could, the hard part about RF quack would be actually finding it if you put it in a really good place to hide it.
Yes.
So you could look and try to find things like that as well.
Right. Okay, so here's a question regarding news about cranes collapsing. Could it be possible that someone is actually using these techniques to create this physical damage?
It is possible. There's no evidence of it because you can't do forensics on these machines. That there's no logs of who did what or what transmitter did anything like that. So is it possible? Yes. Does anyone know? No.
Could the same, well, this is a scary one. Could the same methodology be applied to acoustic systems, control systems, used to remotely control subsea safety systems? For example, remotely trigger subsea blowout preventer on a drilling rig.
Yeah, so actually part of this project is kind of continuing, and we've looked at fireworks launchers. We have looked at the avalanche systems. These are all using sub-gigahertz radios that tend to have little to no security on them. So yeah, in essence, what we have found is if it is a custom protocol and sub-gigahertz, you likely will have no security on it.
Okay, so it would potentially be possible to disable safety systems on a drilling rig?
Yes.
Okay. So how long did the reverse engineering of this, your research here, and the attack tools take from start to finish?
We started this in 2017 and released those vulnerabilities all the way through December 2018.
But was it full time or?
Yes, and no, we're always working on multiple projects. But this one was, we did a bunch of work and then we had to work with the vendors and we kind of waited till all that was done before we released the findings.
Would it be possible to estimate in man hours or
No.
man weeks, man years?
Not right now.
Okay.
Come back to me, I'll go talk to my boss. I'm sure they tracked it.
Oh, yeah, look at your time reports. Isn't it kind of interesting that commercial wireless products for home use, which cost a fraction of the cranes, have a proper security implemented?
Yeah, a lot of it's because the necessity to have that security implemented was there. So it's now on your garage door because people were doing replay attacks, opening your garage door and stealing your things out of your house that way. It's the same thing with car key fobs. The security came out of the necessity because the attacks were actually happening.
Have you run into collision detection systems on cranes using radio signals?
No, as you can see that we were able to do the EStop, we can actually have an example where while transmitting the signal, another signal comes in, it tells it to stop. Because EStops are always meant to always overtake everything. So even if the crane stays stuck and the button gets stuck, that EStop will work.
Okay. Have you been able to reverse engineer the wireless HART protocol with normal devices like cell phones or laptops?
Which protocol?
HART, wireless HART.
You'll have to talk to Reed Whiteman about that one. I've looked barely at HART, so.
Okay. We should talk to someone else then. So how is this different from car remote starters?
Car remote starters use the same systems that, if I remember right, that the key fobs use, so there is a rolling code.
I think you answered this one. Are there any confirmed attacks on cranes? And you pretty much said it's not possible to
It's not possible to say unless somebody came up and said that they did it.
Okay, and that's likely.
Yeah.
So can a similar approach be followed for IIoT devices?
Yes. This should be a standard approach for reversing many of the industrial IoT wireless protocols.
If you started such a work, what do you expect to find?
If same findings, likely hardly any security. If it is, good. But we really need to test to see if these vendors on lots of these wireless protocols are actually doing security.
So each vendor has had its own protocol. Generally speaking, what was the most complicated way you saw to send an up message?
The most complicated way to send an up message. I think when you press the start button or the up button and then release it, those are two different packets. I thought that was pretty complicated, but it also makes sense to save battery life because if you use it heavily, the batteries will die pretty quickly.
But isn't that also a risk? I mean, what if you miss the next packet?
They had some checksums and things like that to say that they got it and not.
Right, so no risk. Low risk?
It was low on the ability that you, unless I said in that case where you are able to keep taking away only the button release packet itself out of the air, then it's possible that the risk is there, but those attacks are not the easiest to pull off at times.
Yeah, but I guess there are some kind of safety measures also in the receiving side, like even if you move a crane, like the
yeah,
board that you moved,
eventually it'll hit something
and then stop.
And then it'll stop because
Yes.
it hit its max
Right.
motion. And so again, there's the physical safety systems for these that tend to be harder to override, such as the governors and things like we talked about earlier.
All right. No more questions.
All right. Well, that was easy.
Thank you so much.
Thank you. Thanks, everyone.